Alright, so when a real-life problem is modeled by a system of linear inequalities, you can solve the system graphically. Okay, so this is what we've been doing. We're going to start to apply it to a real-world problem. Okay, and this is called linear programming. So we've got an example. We're going to write all of this down.
All of the text or what you write?
Everything.
On the board?
Yes. So we've got a furniture making company which makes desks and chairs, and we're given the following information about it, which we will go through in a second. Okay, so we're going to get it all written, and then we're going to try and determine the number of desks and chairs that the company should make so as to maximize their revenue. Alright, so we've got a lot of information going on here. We've got a company that makes what two items?
Chairs and desks.
Chairs and desks, and we're told that they have to do what to both the chairs and desks?
Make and varnish.
Make and varnish, okay. We're told it takes 8 hours to make a desk. How long does it take to make a chair?
2.
How long to varnish a desk?
A desk 4.
How long to varnish a desk?
2.
Okay, and how long to varnish a chair?
1.
Okay. And we're told that in 1 week there are 400 hours of working time to make desks and 120 hours of working time to varnish them. Okay, so that is all the kind of information that we need to set up our equations, okay, or our inequalities really. We're then told some information about how much they can sell these for, and what we have to determine is the number of desks and chairs the company should produce in order to maximize their revenue. Okay, and revenue is just how much money they're going to make. Okay. Right, so first off, we're going to need to define some variables. So first, I've written down here, let x equals something. So what do you think we're going to let x equal if we're talking about these chairs and desks and things?
X equals chair.
X equals chair. I need more information
X
than that.
equals make.
X equals chair.
Y equals varnish.
I'm talking about making desks and chairs. Okay? That's kind of what we're interested in. So I'm told how long it takes me to make desks and chairs. But what I'm not told anything about is what?
How many can be made?
How many can be made, right? Okay, I'm not told about anything about how many can be made. The question says, determine the number of desks and chairs, okay, that they can produce, okay? So the question's asking about the number of desks that can be made, the number of chairs that can be made. So, thinking again then, what do you think we could let x equal?
Number of chairs and desks made.
Right, okay, so we can let x equal the number of both desks first. And y can be the number of chairs made. That's often the hardest bit for this, okay? Alright, now we need to kind of come up with our equations. Let me change colour. We're told that in order to make desks and chairs, we're given what's the maximum amount of time we've got? 400 hours, okay? So using the information for making desks and chairs, can I use the information that we're given regarding the time and our variables? So can we put it in some kind of an equation? Okay, well here's a question for you. Let's say that I made, don't write this down, a bit in red. If I made 3 desks, how long would that take me?
24 hours.
Okay, how'd you get that?
8 times 3.
Okay, yeah, I did it. Because it's 3 desks and I'm timesing it by 8. If I made 4 chairs, how long would that take? How?
4 times 2.
Right, okay, because it's 4 chairs and it takes 2 hours for each of them, yeah? All okay with that? One second, John, okay. If I then change my mind here and say that I made X desks, how long is that going to take me, John? If I make X desks, X number of desks,
X times 8.
Yeah, which is
Yeah.
8x. If I make y chairs, it's going to be,
2y.
yeah, which is 2y, okay? And that's exactly what I've got here. I've got x is the number of desks. So if I make x desks, it's going to take me 8x, because it's 8 hours to make a desk, so it's 8 hours to make x desks, plus 2 hours to make the number of chairs, okay? And in terms of time, what's the maximum amount of time I'm allowed to do that in? 400, right. So I've got that this is going to be something to do with 400. Now, I can of course make this quicker than 400 hours, yes?
Yeah.
Okay, I'm not allowed to make it after 400 hours. I have to do it either 400 hours or less. So how can I write that as an inequality?
Less than equal to.
Right, less than or equal to. Okay, so we're saying that if we're making x desks at 8 hours a desk and y chairs at 2 hours a chair, the time that it takes me has to be less than or equal to 400 hours, okay?
Should we write that?
Yeah, so write that bit down, okay?
We don't write that part.
You don't need to write this bit. So this is us coming up with our equations. So I've used this piece of information, this piece of information, and this piece of information. Okay, and this is to do with making chairs and desks. Can you write me down an equation to do with varnishing the chairs and desks? See if you can write me an equation, or an inequality, I should say, to do with varnishing the chairs and desks, okay? So that'll be to do with this information. And we're told we're allowed 120 hours to varnish them. So see if you can come up with an equation using those. Give you 30 seconds. If I'm making the desks, I'm also having to, so it's the number of desks made, stroke, varnished, okay? Because it's the same thing. Have you got an equation, Ian? Yep.
2x plus 1y is less than 120.
Right, good. So I've got 2x, okay, because it's 2 hours to varnish a chair. Okay, and this is the number of, sorry,
Yeah.
listening. It's 2 hours to varnish a desk, so it's 2 times x. It's 1 hour to varnish a chair, so 1 times y, and that has to be less than or equal to 120, okay? Because they can do it in less time, okay? Or they can do it equal to that time. Everybody okay so far?
Yep.
All right. So, what we need to work out is the maximum money that we can make if we're going to sell them each for this amount, okay? What do you think we're going to have to do next? Given in mind, taking into consideration what we've been doing the last couple of days, Eliza?
Try to find exactly the number of desks made.
Yes. Yes, but how do we do, like, why did we do that, John? Yes, okay. But then what are we going to do? Like, what's kind of, yeah. What are we doing yesterday? Grayson?
You have to isolate the Y.
Yes,
And
what
then
did we
do
do
the charts.
yesterday? What was that yesterday and the day before?
And then you do the charts, and then you do the graphs.
Say again? We
Isolate the Y.
graph them, okay? We're
Yeah.
going to end up
graph
graphing
it, yeah.
these, okay?
Yeah. Good job,
And we're going
guys.
to look for the particular region that this covers, okay? Now, in order to graph them, it's easier if we isolate the, yeah, so I think it was John said, if I want to rearrange this so it's in terms of y, talk me through it. What do I do first? Well, I'll subtract the 8x because that'll make it a bit easier.
So right now you're left with 2y is less than or equal to 400, so take away 8x.
Yep.
And then we're going to multiply by, divide by 2 over 9.
Yep. So I end up with
Y equals
y is less than or
y
equal
less
to
than 200
200 because I'm dividing everything by 2
Minus 4, 4.
minus
4x.
4x. Okay, so that is one of my equations. Okay, we have to do the same with the other one. Luckily this one's a bit easier. So I'm going to subtract 2x off from both sides. So I get y is less than or equal to 120 minus 2x. Okay, so that's my second equation. Can we turn it off, please, whatever it is?
Oh,
Whatever it is, please turn it off. You're not going to get in trouble, just turn it off. Right, can we remember how we draw these? What do we have to do first before we even draw them? Okay, all right, we're going to do a table, okay? So, set up your table. I have got a graph paper for you to do it, which I'll give out now. So for your table, pick certain values. Looking at the graph paper that I've given you, I would pick 0 and maybe
Oh, do we do the ones you're using? Or,
you can pick your own or you can use mine.
alright. I'm doing -4, you know, 4. Yes, Ian?
Why'd you go up in 25?
Okay, why did I go up in 25s? Why? Look at the graph
I
paper.
mean, I know, but because of the graph, you can take it
Yes,
away.
Ian?
Yeah, it'll make it easier if you kind
Yes,
of look
yeah.
at the graph.
The transfer information?
Yeah.
Yeah. Almost.
What did you do? I
Yeah.
did a PowerPoint.
Why
Same.
did you,
Materials about.
why is,
Okay, so whenever I come to plot that, I've got 0, 200. So it's going to go through this point, 0, 200. It's going to go through 25, 100. 25, 100, which is here. And it's also going to go through 50, 0. Okay, so you're plotting your points. Now, make sure it's nice and neat.
You pretty kind of ruler.
No, I do not want the dotted line. Can we not use those rulers? I told you yesterday we do not use those rulers. Those are not my rulers, so don't use them. Use the ones on top.
We put the original equation, right?
Do you have one?
You can put either. But I would put I recommend putting the one that we've changed, okay? So for example, that's that equation, that is the first one. So y is less than or equal to 200 minus 4x. Okay, see if you can get the other one drawn, okay? What are the values that need to go in here then? If x is 10, 100, and then, yep, this is going to be 50. So I can plot these, 10 and 100. Let's do it in green. So 10 and 100. And what was the other one?
35.
accurate as possible.
Oh, sick. This one.
Let me just extend this. If we want to go the whole way out.
I should use different numbers. They're liquid.
So we should get something like that, okay? Now, the more accurate they are, the easier this will be. So this the second one is y is less than or equal to, what's the equation? Right, yes?
I thought you were gonna be y equals 1.9.
Okay, okay. Technically, the line is 1 equals, okay? So when we come to shade it, then that is the bit that's less than, okay? So you're right. The line is, yeah, that's a good point. The line is actually y equals for each of these. I'll not be too fussy about that though. Okay, and then when we come to shade it, that is the bit that is less than or equal to, okay? Are you okay, Zaire?
Why do we have to go based off of your graph?
Why do
Because
we have
every
to-
time I tried a couple of different numbers in the table, but they didn't really work well because of the graph you had already made for it.
Yeah, so I made the graph just to kind of make it easier in terms of getting the scale correct. Now, if it's if it's an exam type question, you'll be given this graph with the scale, okay? So you'll kind of have to figure out, okay, what points are the best points to use in order to be able to draw it as accurately as possible. Now, if I want to shade, oops, it is the, let's get rid of
Oh,
that.
I got this
If I want to shade y is less than or equal to 200 minus, sorry. Am I going to shade underneath or above this line?
underneath.
Underneath, okay, right. So I'm going to shade underneath. So it'll be all of this stuff. Now I'm going to shade it, but you just watch for a second. So it'll be all of this stuff, yes?
Yep. Yep.
If I want to shade y is less than or equal to 120 minus 2x, it's going to be, Underneath the green line. so it overlaps, whereabouts? In this part here, okay? So let me just shade that in so you can see, okay? So it's going to overlap. Do it in yellow and this part.
Oh, is it a serious issue? Let's not talk about it.
Not that serious.
How's it a serious issue? Topic fun of topic fun of
Just not the best at drawing.
Right, so this is the part that we have shaded, okay? Which is determined by our inequalities. Does everybody understand how we shaded this part?
Oh
This is
yeah.
all the type of stuff that we've been doing the last couple of days. So
That's
far.
the overlap zone. Aha.
All right, so everything in this shaded region is true for both of these inequalities at the same time, correct?
Yeah.
Okay, so we have our possibilities then for our answers are going to lie at certain points, okay, on this line. Okay, we've got this point, Now, if you've drawn it correctly, this point where the two lines intersect will be 40 and
50.
it's not 50.
Yeah, easy.
In between 25 and 50.
That's the lowest.
No, I know,
That's
Bob. It's
not.
not.
Guys, come on.
It's in between.
It is 40 and 40. Okay. We've also got other points where these were. So this point. Okay.
Line intersected at
So the two lines intersect at this point at 40, 40. We also have this point where the purple line intersects. Okay, what is this point here?
50-0.
Right, good, 50, 0.
Good job.
What is this point? It's slightly off because of the way I've drawn it. Oh no, it's yeah. What's this point?
0.
It's going to be 0.
100.
Use this line to help.
Oh.
If x is 0, what is the line crossing the y-axis
Oh,
at?
120.
120. Okay, because if x is 0, I get 120 out. Okay. So these are my important points. Now, what does this? What do these numbers correspond to? What does the x value correspond to?
The amount of
Go back to the start of the
Yeah,
question. What does
let's
the
see the
x
question.
correspond to?
The
amount of
This is
tables.
how
Number.
the amount of
It's the
Number of
number.
desks.
decimated.
Number
the
of
amount
desks.
you're trying to meet.
And y corresponds to
Number of
Number
chairs.
of chairs.
number of chairs. Okay. So my possibilities, okay, in order to try and maximize, and we need to test them, is I've got 3 possibilities. I could make 0 chairs, but I could make 120 desks. My other option is to make 40 chairs
And 40 down.
and 40 desks. And my other option is to make
50 chairs.
Yep.
50 desks. And
no 50. Sorry, yes. Sorry. 50
Oh, yeah.
desks. Why have I written that wrong?
50 desks.
Sorry, I've written up the wrong way around. Sorry, my bad. So that's 0 desks,
Yeah.
120 chairs, and this one is 50 desks and 0 chairs. Okay, so these are my possibilities, okay? Refocus. These are my possible options, okay, in order to try and maximize profit. Now we're told back at the start of the question. Alright, I know I'm going fast here. How much did it say that we could sell a chair for?
No.
It's a
$20.
chair for
$20.
$50.
$20.
$20 for a chair?
20.
Yeah,
$20.
20 and 50 for that.
50 for a desk. Good job, John.
And $50 for a desk. Alright, can we come up with an equation for R, for revenue, which is how much money we're going to make in terms of this and using our X's and Y's? Because remember, X is the number of desks sold, Y is the number of chairs sold. So can I use this to come up with an equation?
R equals 20x. No, wait, it's x chairs.
Yeah, which way around is it?
It's 20y
Plus
plus 50 eggs.
Right, okay, good. It's $50 for a desk. Shh,
Ooh.
stop and focus. So this is our equation for our revenue. So in order to figure out how the one that's going to make the most money, we're going to end up putting this in a table, okay? So we're going to have our value for x, our value for y, and then we're going to have 50x plus 50y. Okay, and we're going to use this information, okay? So if I've got 0 desks, that's my x, and 120 for y. I'm going to have 40 desks and 40 chairs. And then the last option is 50 desks and 0 chairs. Okay, and I'm going to put these, my values for x and y, so this is like our option 1, option 2, option 3. Putting these into my equation to work out how much this is going to cost. So 50 times 0, that's my x, plus 20 times 120. I can have 5 times 40.
Wait. Why would you do 5?
Yeah.
Yeah.
Oh, it should be a
50.
yeah, 50, sorry, my bad.
Really?
And then 50 times 50.
And shouldn't that be 20 instead of 2?
Oh, yeah, sorry, thank you. Rushing as I am, I know it's forgetting close to the end.
Oh.
So this one would be 3,800. So which one provides us with the most revenue?
Wow.
The middle.
Yeah, the middle one, okay.
Wow.
So in order to make the most money, they must make 40 chairs and 40 desks. Have we all got that down? Have you ever pulled the book up? Okay, these are hard questions. There is so much going on here.
Yep.
You have to be able to rearrange equations. You have to be able to graph these. You have to be able to do your inequalities. You have to be able to solve them. You have to then be able to do substitution. Okay, this will go on YouTube, so make sure you have a look at it, okay? We'll do another one tomorrow, and those people who are not here, please make sure you go on and have a look, okay?
When?